Hello everybody, so far you have seen how to generate fixed points with exact coordinates or creating grids or spheres. But what if you want points to follow an existing shape, like a surface or a curve, have points being driven by a texture or a volume in your level? So that's where sampling comes in. It's the bridge between geometry and logic. So sampling lets you generate points based on another input. If you give it a shape, like a surface, curve, or volume, or a texture, it will give you back a list of procedural created points. And each sampling method has its own rules, as they often do different styles of generation. So let's see what the different samplers are and when to use them. The surface sampler is one of the most popular samplers in the PCG system. It lets you generate points directly on the surface of another mesh, like the landscape element or the terrain that you build from static meshes. You can add some additional terrain elements or foliage onto them, or covering some surface into moss and snow or some other objects. An example we'll be generating right now is fill in some area with procedural foliage. So let's start. Let's see how this example was created. And first I'll disable all of the spawning and just show you the surface sampler. So we'll currently be sampling the landscape. So start with get landscape data node. As you can see in my example, I started with that, and then I used the surface sampler. And we'll now connect it to a debug node just to visualize the points and see what the different options do. So the points per square meter is exactly like it sounds, how much points you will get for each square meter. So if you put 1, and if I reduce the point extents to be under a square meter, so it will be easier to see, and I put the looseness to 0, you can see that for each square meter, or each of the squares on my landscape is a square meter for each square you can see here, I have exactly 1 point. If I put 2, you can see that roughly for each square meter you have about 2 of these squares. So 4, you can see that in each square you can fit 4 points. And this looseness parameter controls how much they are arranged in a grid pattern or how much they are just randomized in the space that they occupy. But again, they still try to be about 4 per square meter, like we had it set right now. So the points per square meter is the density of the points you put. The extents, as you remember from any of the last tutorial, is the extents of each point. And this unbounded checkbox will apply these settings to the full landscape, not just the area in your bounding box. But always when you use unbounded samplers, you need to be careful because there are some limitations to this. So let's see how we can use this surface sampler to create the forest scene that I showed you before. I'll delete these example nodes here, and I'll start by first enabling the trees and the bushes. So here I have this surface sampler with the points per square meter of 0.02, and the extents of the points is 8 units in each direction. So let me debug the points, and I'll increase a little bit the extents. I have it to 8 because it matches roughly the bush's stem. So, but it will not be a problem to be a bigger area. So it's easier to visualize like this. So let's see what we are doing. We are just applying random rotation to our points of 180 degrees, and then we are spawning a tree or a bush. we have two different bushes and one tree in our static mesh spawner. So in the mesh selector we have added 3 mesh entries, and into the descriptor we have connected a bush, a second type of bush, and then in the third one type of tree. And that is how we create this area with trees and bushes, and we can control the density, of course, by this points per square meter. And the next example right here. So we are using another surface sampler because we want a denser area to cover with grass and rocks. So let's debug these points, and you can see that we have much more points right now. So for these points, we apply again the same transformation, which is just a random rotation between 0 and 180. And if I connect this to the debug, you can see that they are now rotated. And actually we have some scale randomization from 0.8 to 1.5. So we have different type of rocks and grass. And then we are using a random choice. So part of our points are going here into the chosen pin and the other part into the discarded pin. And the points going into the discarded pin are used to place rocks, and the points that are going into the chosen pin are used to create grass. And this is the whole logic behind this area. And the great thing about this sampler is that it will apply this logic exactly to your landscape. So it doesn't need to be a flat area like we have currently. If you move it to some part where your area is affected by the landscape sculpting, you can see that it conforms perfectly to the landscape. So you don't need to manually place objects. And one of the things that you need to be aware of and to control when you use this option. For example, right now you can see that on the slope of my mountain, the trees are sticking to the side because they are taking the angle that the slope is having. So they are applied to an angle. So that's why I'll be using a different Gantt landscape data node to the top sampler where we are placing these trees, and into the get landscape data, I will check this get height only checkbox to true, and this way it will not take the direction of the landscape, it will just take the height where it needs to place the object. So you can see that with this checkbox you can control whether or not the objects are following the terrain with the position or as well with the angle that they're being placed on. So this is very important for the landscape data, so make sure that you have this checkbox in the way that you need it. So let's continue. The next most commonly used sampler is the Spline Sampler. It will sample a spline that you generate in your level, and it will place object along the spline. And this is fantastic if you want to create a path or some fence or a road or vines. Let's see an example. So to start, you need to have a spline in your level. You can make a blueprint with spline component or go directly into the modeling mode and choose the draw spline tool. And the easiest way will be with the free draw tool, and I like to use 1000 units. So when you drag inside the level, it will create a spline with a control point in each 1000 units. And after you hit accept, you have the spline actor in your level. You can find it in the outliner by searching for spline actor. And here into the details section, you can search for tag, because you need to add some tags in order for PCG to find this spline in the level. So let's add tag and call it spline. So now, when you create a PCG graph, so when you drag the PCG in your level, make sure that the bounding box is around the spline that you have created in the level. So now, in the get spline data tag, so you can get this by searching for get spline data. And here you need to specify that you want to search in overall actors, and the tag that we just gave the spline, this will find the spline in your level. And if you inspect the node by hitting the A key or right click and inspect, you can see here we have a list of points that create this spline, and we can use a spline sampler to sample this spline, and let's connect it to a debug node to visualize the points. And this debug node is using the absolute point scale, because if we use the extent, you can see the points that are created from spline samplers are just very thin, long bounding boxes, so it's hard to see from far away. So let's go to the absolute type, so it's easier to see. And the different options in your spline sampler are the subdivision, the distance, and the number of samples. So the subdivisions is basically how much points you want for each control point of your spline. So currently it's 1. If it's 0, it's creating just a PCG point on each spline control point. With distance, it's creating a PCG point on each X number of units that you enter here into the distance increment in world units. So if I put 200, each 2 meters, you have a PCG point. And you can create a start and end offset. For example, here, if I add an end offset of 200, you can see that the last 200 units of this spline will not have a point created for them. If I increase that to 2000, you'll have a bigger gap at the end. So let's go back to 0. And the number of samples is just how much points you want for the full spline. So if I go with 1, it will be just a single point. If there are 2, it's 1 at the beginning and 1 at the end, and so on. So these are the 3 modes that you can have for generating points on spline. You can generate points on interior of the spline, so it will be an area defined by this spline. So let's go back to our level. Let's select the spline that we just created, and let's mark the closed loop checkbox for the spline. So in the spline actor, select the actual spline component here, and into the details panel, find this closed loop checkbox, or here search for closed, and it will find it. And if you check it, you can see that the spline is automatically closing between the first and the last point. So when you go back to your PCG graph, now if I choose the dimension to be on interior, you can see that it's filling the area defined by this spline, and it's filling it with a grid based on the numbers that you enter here. So for example, if I increase this to 200 or 300, it will have less and less points, and if I make it smaller, like 10, it's creating even more points than we had by default with a value of 100. And the border sample spacing, let's go to something like 200 to see the individual points. And now let's increase the border sample spacing to 2000, for example. You can see that it's creating a bigger intervals between the point on the spline that's using to define the area. So if you have a smaller interval here, like 100, it will follow better the spline that you drawn in the level. And if you have a bigger interval, it will just make a very simple shape from this area and fill that with the points. So depending on what you want, you can control these 2 parameters to define how are you creating the points. So let's continue to see how the example with the fence is created. So I'll delete these points and I'll move back the bounding box and regenerate the fence. So right now you can see that it's consisting only of these three nodes. The first one is the get spline data, and we are taking the spline with the tag that we defined in the level. After this, we are sampling on distance, and the distance is 250 units, and this is the distance that we need for this fence pieces to match up. So if we increase that to 300, you can see that there's a gap between each piece. So that's why we use 250 world units. In that way, the fence is getting good intersection between the beginning and the end, so it looks like it's connecting properly. And in the static mesh spawner that we have here, we are just placing a single static mesh on each point on our spline sampler. So this is very similar to the sampling the landscape or some surface, but instead of sampling a surface, it's sampling the spline in your level. So you can control the direction and the position of the points in your level. Now let's see how we can sample a texture. Sample texture allows you to drive the point placement based on a file texture. This opens up a cool workflows. You can paint some masks in Photoshop or even Paint and apply modifications or logic to your points placement based on the colors of this texture. So here I have a texture file, and I want to use this to apply some different spawning into my surface sampler points. So here is the setup I have. I'm having the same setup for the surface sampler, so I'm getting the landscape data and then using a surface sampler with the points per square meter of 1, and my extents are set to 20, 20, 20. And let's connect this to a debug node. You can see that these are the points that the sampler is generating, like in our example of the surface sampler. But this time we are using a sample texture. So we need a get texture data node, and this get texture data is connected to our base texture of the sample texture node. And here we have connected the texture that I showed you earlier, this image, and we want to drive some placement with the green, red, and yellow color. This sample texture node will get the data from the texture, and if you inspect this node by right-clicking and inspect, or marking it and clicking the A key, here at the bottom in the attributes, if we scroll back here, you can see for each of the colors, the points have a value assigned to them. So the ones that are in the red circles of the texture, they have a value assigned as 1 for the red channel. The ones that are in the green part of the texture have a value for the green color set as 1. So by using this color data that you apply for the texture, you can then filter the points. So if I connect this sample texture to the debug node, and now let's use the color of the points instead of the density. If I click the color, the debug node will show you the color value that the point contains. So all here in the middle are black. Here we have green, yellow, and red. And if we want to filter these results, let's connect this to the next node. Let's disconnect the debug. We have 3 filters. First, we are filtering by the color green by using this $ color point G, which is short for green. Then we are filtering for red, and here we are filtering for red as well, the ones that are not containing green. So here, if we filter only the points that contain green, let's connect this to the debug. Let's disconnect the static mesh spawners. So all the points that contain green are the green points and the yellow points. So this is the result of our first filter. And then if we go to our next filter, so if we show the points that have a red value smaller than 0.5, so they don't contain red, this means that we'll filter out the points that are in yellow, because the yellow is containing both red and green. And the points that are outside of our filter here, they be only the points that are containing both red and green, so the yellow points. And similarly here, the points that does not contain green, let's connect them here, they are the red ones and the black ones. And here, if we filter only the ones that contain red over 0.5, and again, I'll be showing you filtering in the next video, so you'll have more details on these nodes in the next tutorial. But just to show you the example here, let's connect this filter to this debug, and you can see it's filtering only the red points. And if we need to place something in the middle and the dark ones, you can connect these outside points, and it will contain all the dark points, the black points in the middle. So if I enable the static mesh spawners, the first one of them is spawning this oak plant. So it's the spawning on the green points. The second one is spawning this small sapling, so placing it on the yellow points. And the last one is spawning these rocks and placing it on the red points, which I have here and here. So if you look from above, you'll see that it matches our texture. So we have, it's flipped this way. Okay, so we have the 3 red dots here at the top, and we have these 3 rock clusters at the top. Then we have 1 rock cluster here at the bottom where we have this red point, and the bottom left and top right parts are green, and in the middle next to the black part we have this yellow point spawning the small saplings. So this is the basic setup of the sample texture node. You need the get texture data and sample texture node. And lastly, let's look at the volume sampler. The volume sampler generates points based on the volume. It's like a 3D version of the surface sampling. You can use this node to put some particles in the air or fishes in the ocean or build up some volumetric shapes. So let's look at some example right now. So let's select the example graph I have here, and let's start with just showing you how it's this created. So first we need to get some data for our volume sampler. So we are getting the actor that contains this PCG component. So this get actor data will return you with this single point node just the bounding box of our PCG volume in our level. If we increase the size, for example, let's put 5 here, we are increasing the size in that direction. If we go back and connect this instead of the debug to the volume sampler, you can see it's filling the full volume with points, and these points are spawning a static mesh, which is this oak seedling. This one is just placing a lot of these objects inside this full volume. And to make it a little bit more interesting, I am transforming this bounding box here. So let's disconnect the volume sampler and show you. This bounce modifier will change the bounce from the original shape, which is this dark shape on the outside, to this inside shape, which is this path that we will do through the volume that we are filling with our objects. So if I connect this, you see I'm using this difference node in order to cut out this path inside the volume. So this difference node is set to a binary mode, and then we are just outputting our static mesh here. So the volume sampler is sampling points inside your full volume that you connect here into the volume pin, and you can control the density by increasing or decreasing these numbers. So you can see now they are each 50 points spawning this static mesh, but if I reduce it to 20, it's much more dense, and if I go to 10, it's even denser. Now you've got a full toolkit for generating points in any way that it fits your project, from splines and surfaces to grids, textures and volumes. In the next episode I'll show you how to filter and modify these points so you can truly generate dynamic contextual content into your levels. Subscribe if you are following along these tutorials. If you like to watch the tutorials earlier, you can join the channel into the higher levels. You'll have an access to the tutorials before everyone else. And guys, I'll see you in the next one. Bye.